In this lesson, in this warm-up, I'm having students compare simple interest to compound interest and the type of functions that they create when we graph those functions. And so we have, for simple interest, you can see that it's increasing at a constant rate of change, that it's earning the same amount of interest each time, $187.50. Because on simple interest, we talk about you take that principal amount, which is $5,000, and you're going to multiply it times 0.0375, that interest rate from the percentage that you write as a decimal, and you get $187.50. So each time we always go back to that principal amount, that starting amount that you deposited, $5,000, and calculate the same interest each time. So it's a constant rate of change. So when we graph that on the graph, on table for graph 1, if we go by 200s for the y-axis, and it's hard to write these in there, but each time it's going up almost 200 to almost to 5,200, 187.50 added each time almost brings it to the next 200 amount. And so when you look at year 1, 2, 3, and 4, it is a linear function because it's increasing at a constant rate of change. When you look at the next one, and you still set up the time versus the money, so the time was in years, and this is the amount of the new balance, and we still go by 200s on the y-axis for the next one, and ones for the years, for 4 years. You can see that on compound interest on the second graph and table, you take the amount $5,000, the first amount, and you still get $187.50 for the interest. But when you go to the second year, you take the new balance, $5,187.50, and they could have just substituted into the formula that I gave them, or figured out that it was compounding interest off of each period, which was in this case years. $5,187.50 times that 0.0375, and that gave them the new interest amount to add on was $194.53, and which that gave us a new balance of $5,382.03, and then we took that new amount, $5,382.03, found the interest of that again, multiplying times 0.0375, and that ended up adding on $201.83, which brought up the new balance to $5,583.86. So it is increasing more rapidly with compound interest, and if we try to graph that, we can see that it's not linear, because even though we only looked at the pattern for the first 4 years, because it's going up more than just at a constant rate of change. The first one went up the same just because it was the first year and it wasn't calculating off the same balance as simple interest, but the second year it went up more, almost to the 5,400, closer to it, and then the third year almost to 5,600, and the last year almost to 5,800, and you can see that it's going up more rapidly, and if you continue on, it will just increase more rapidly, where it will end up curving and be an exponential function that we'll talk about more instead of linear. And that's what we're going to look at in this lesson, is comparing the different patterns that present themselves when it's linear and increasing at a constant rate of change, or when we look at the table, also if you divide the previous amount that we previously talked about in the other lesson, that it forms an exponential function. So you definitely would pick to count 2 with it being compounded yearly.